So now we're going to talk about everybody's least favorite topic in counseling, and that is basic statistics. So I want to just make you aware. Okay, so that's what we looked at before. Okay, so in week one, I gave you all the research class notes. So if you click on those, you can actually go through and use these as a study guide for the NCE, the section on stats, or comps, the section on stats. These are actually the notes I studied when I took the comps and stats and when I took the NCE. So, and they're pretty extensive, as you can see. So this walks you through all kinds of definitions and all kinds of things. So that's kind of your study guide for this. So don't worry, everything I talk about is either in the book or it's in the notes. You don't have to worry about writing everything down for this. Okay. So my version of the book does have a chapter called Basics of Statistical Method. And in edition 2, it's chapter 3. I know edition 1 has it. I'm guessing I don't have a copy of the 3rd edition, but I'm pretty sure it would have it as well. So, we're going to start with basics. That's what this is. But between this class and assessment, tests, and measurements, those two classes comprise the section on counseling, statistics, and measurements, basically. So between what I teach you in this class and what is taught in assessment, tests, and measurements class, that's the section of the comps and the NCE. The first thing I guess we'll talk about is scales and scales of measurement, because these are always, and so let's say I talk about a topic like scales of measurements. I'm going to talk about maybe 4 types of measurement. There's only going to be one question on the comps or the NCE. And it'll probably give you an example of one type of measurement. And it'll say A, B, C, or D, and it'll list all 4 types of measurement. You just have to say which one it is, okay? So even though, these are fairly large, multiple paragraphs in the book, it's one question on the exam. And they'll throw everything into A, B, C, D, multiple choice. So one of the ways I'm going to explain things in this topic is basically I'm going to talk about easy ways to remember these. And if there is a math problem, a stats problem, I'm going to tell you basically easy ways to figure that out, because you're only going to have a minute for each question. So you don't have time to do a 5 or 10 minute math problem to figure out standard deviation. you're gonna have to figure out a way to do these things quickly and to get really close so that you can guess, is it A, B, C, or D? You know, you might not get an exact answer, but you'll come close enough to pick which answer it is. Okay, so that's kind of the way we're going to do this. So when we think about the different scales, there's, nominal, ordinal, interval, and ratio. So that's going to be A, B, C, D. Those are your four choices, basically. So there are slight nuances in stats, like there's a difference between numbers and numerals. Okay, so numerals are defined in terms of symbols, such as letters or words, so male or female. The interval between units cannot be assumed to be equal. So nominal and ordinal scales are considered numerals. Numbers are values where we can perform a mathematical problem. So I want to kind of give you an example of this concept of numerals versus numbers. Numbers are easy. Numbers you can add, multiply, subtract, divide, okay? You can do any math equation with the numbers. However, numerals do not have a value, okay? It's more like a label. So, for instance, if you're using SPSS, the statistics program, and and you just want to say, okay, how many males or females or other, whatever, however you want to designate it, were in this study. So you can't type in male, and maybe you've got 1,000 different people. So as you go through each result, might be a survey on a piece of paper or something like that, you're going to code, okay, males are going to equal 1, but it's not the number 1, it's the numeral 1, because you can only really type either numerals or numbers in a stats program. Females going to be numeral 2, and other numeral 3. You may even want to provide a blank so that people can express their own identity. So the way it treats that, it treats the numeral 1 as a symbol, okay? And it's going to end up counting how many times I typed in the numeral 1. And it's going to count how many times I typed in the numeral 2. Because it's not seen as a number. It's not, it's seen as a symbol of male, female, other, okay? So that's just kind of a basic example, all right? So let's talk about these 4 different scales a little bit. So nominal. The word nom actually means name. Okay, I forget whether it's Latin or Greek, but the origin of nominal, nom, the root, means to name. Okay, so I think that's a lot of the example that I just gave. So you could also do this with ethnic groups, so you could say, okay, Latino equals 1, African American equals 2, Caucasian equals 3. So you're really just assigning a numeral to the name of a group. And it could be anything, you know, it could be, if you're working at a wildlife refuge and you've got 100 different kinds of birds, you could say, okay, these are robins equal 1, you know, eagle equals 2. You can do it with anything, okay? So I just remember nominal equals name, okay? All right, so another word that's related to nominal is a nomination, okay? So, and that simply means like a category, okay? And it could be any category. So that's considered a numeral. You can't really calculate that. It's really just for tallying. All right. The second one, ordinal. Okay. So just want to give you an example here. So ordinal is easy to remember. Ordinal equals order. Okay. So it could be like if you were in the military and you wanted to say, okay, so there's different ranks, you know, in the military. There's like private and lieutenant and captain and major and colonel and general. Okay, so there's an order to ranks in the military. That's why they call them ranks. It is a ranking order. And so ordinal or order equals position, okay? It's also a numeral, you can't add it up. But, you know, you could give a numeral to each rank or each type of rank. You can't really calculate these beyond tallying as well, but you can place in order, basically. So, you know, you can do a ranking with this. So it's a little different. It's not just a name of a category. You can do order and ranking with ordinal. All right, so those are the two numerals, right? And the next ones are considered numbers. And remember, a number you can calculate. You can do a math problem with these. And there's two types. There's interval and ratio. And and I just want to give you some of the examples here. And how you can tell them apart. So an interval. So every unit or every number in an interval has an equal distance apart. Or, you know, I don't like defining terms by their own words. So interval, the book says, represents equal units or intervals. So I wouldn't use interval to define interval. You know, that's shouldn't have done that. But equal units, okay? So if we just use whole numbers, okay, 1 to 2 is the same distance apart as 2 to 3. Okay, so you know, so it says one of the best examples is the range of scores on an IQ test. We're going to talk about an IQ test when we go over standard deviation. And so you know, an example is 20 to 200. But can an IQ of 0 be measured? Someone could theoretically score 0, but the true score will not be known, cannot be measured because of the limitations of the instrument. So I guess one of the ways to answer this question, if they give you an example, is an interval does not have a true 0 point, and each unit is an equal distance apart from every unit. So, so 0, no 0, that's an easy way to differentiate this from the next one, which is ratio. All right, so this is our last type of scale, and it does have a true 0. Okay, it can be used in everything from time to weights and measures, things like that. So a good example is kind of, Kelvin temperatures, and it's one of the most precise of all scales. You can do mathematical equations with it. You can do quantitative. You can use it with variables. So it represents equal units and it has a true 0. It's a number. You can use it for any operation. All right. So those are like the most basic concepts in stats. I don't really think too much about them. I simply know that I basically know how to use them, and you do too, I'm guessing. You just have to remember what name matches what purpose. Is it, nom, name, so you're identifying, certain category. Is it ordinal? Are you placing something in an order? Is it an interval? So equal distance apart, but no true 0. Or is it a ratio, equal distance apart of units, however, there is a true 0. So that's pretty much the basic way to remember them. All right, so the book does, and my notes, it provides all kinds of definitions. So there's not going to be a lot of math on the comps or the NCE, but you do have to understand concepts, okay? So it's going to give you concepts of variables, concepts of reliability, the different types of reliability. You kind of have to know which one it is. So it'll give you an example and a list of the different types of reliability, and you just pick which one it is. So it's more about concepts, statistical concepts, than it is about actual math, which is good. There's a couple things you might need to know about math, like they might have you figure out standard deviation or a t-score or a z-score, but I'm going to show you some shortcuts for those. So, all right, so let's look at some basic definitions. We'll talk a little bit about each concept, each statistical concept. So one of the problems in your book is that they use a word to define itself, which really isn't good. So distribution. So refers to how scores are distributed across a data set. But, we really don't want to use the word to define itself. So what I usually use as an example is kind of a scatter plot, So if you kind of want to look at a distribution of scores, you might put each score on a scatter plot, and you can see if there's a grouping where a lot of people scored similar results, or maybe it's spread all over the place. Maybe there's a broad range of scores. So you'll come to realize that there is a different type of graphical representation for most concepts. Some are better than others. Okay, so different descriptive stats or graphs work better for some concepts than others. All right. So let's talk about mean, median, and mode. Three types of averages. I see this on comps all the time. Okay, you should know three different types of averages. So this is something that they use in like political ads all the time. They'll use the incorrect average. They'll use a mean when it should be a mode, if it leans in their favor. So you need to know which one you should use for what kind of data. So the average you think about normally would be mean, okay? And that's when you add up all the scores and you divide by the number of scores, okay? So let's say there's 30 people in a class, and I type in each of their grades onto a spreadsheet. So there's 30 grades. And at the bottom of the spreadsheet, I add them up and I divide by 30 because there's 30 grades. That gives you the average mean grade for the class. So that's usually what people think of when they think of the term average. But there's two other types of averages, and each one has various purposes. And so the next one is median. And the way I remember median is basically the median strip in the middle of a highway. It's right in the middle of the highway. So median is the middle. That's what median means. So 50% of the scores fall above and 50% of the scores fall below. And median is like that median strip that divides the highway in half. And then the other one is mode. And mode is simply the most frequent score in a distribution. So, I might have a class and they take a test, and the lowest score might be 50 and the highest score might be 100. And, you're going to count up how many times each score appears. So maybe the most frequent score was 90, maybe 10 people scored 90, and, that was the most frequent score. So that's the mode, which is the most frequent. So we use these averages for specific reasons if we want to look at data a certain way. But they can also be misused, and that's the problem. You don't want to pick the wrong type of average. It would misrepresent the data. So it would be true, but it wouldn't be an accurate representation of the data you're trying to present. So you just really want to pick the right one. And on the exam, they'll probably have an example of one of the three types of averages, and then they'll give you A, B, C, mean, median, mode, D, none of the above, something like that. And you'll just have to say which one it is. All right, range. So a range is the distance between the highest score and the lowest score. So even though I usually use exams with 100 points, the range is not 100. That's the possibility. The range would be the lowest score might have been 75, and the highest score was 90. Okay, so the range is 90 minus 75, so 15 would be the range. So you have a 15-point difference between the lowest score and the highest score. All right. So any questions so far about any of those definitions? I know this is probably the most exciting class you've taken, but you know, it's necessary. Okay. So the next thing I want to do is talk about standard deviation. This will appear usually one time. It'll be one question on the comps. And so standard deviation is the way scores vary around the mean. So we know what the mean is, okay? And how they're stated in standard units or standard deviations. So what I'm going to do is I want to pull up an example. So I might even use, I don't know, maybe IQ. Okay. Some of these are correct, some aren't. Okay. So let's look at this standard deviation. All right. And we're going to talk a little bit about how you're going to interpret scores. All right. So if you look at these, so each section is one standard deviation from the mean or the norm. So when we think about this, you'll notice that these are positive, these are negative. So this is the mean in all the IQ scores. So I just know that 100 is what they call the average IQ. But average doesn't mean, oh, the average person has 100 IQ. Average means mean, okay? So that's how they're using average IQ. So if we look at positives, we can see that this dark blue is one standard deviation away from the mean or 100. So one standard deviation on this 100-point range would be 34.1%. When we look at 13.6, that's two standard deviations. And then 2.1 is the third standard deviation. And there's a tiny little fourth standard deviation away in a positive direction. So what this means is it's not a score. What this means is if this is the mean, if 100 on an IQ test is the mean, and we move one standard deviation away, 34.1% of the population scores will fall within one standard deviation of 100. So that would be people who score higher than 100 within the first standard deviation. So if they score lower one standard deviation, 34.1% fall within one standard deviation lower than 100 on the IQ. If you add these two together, you'll have 68.2% of the population within plus or minus one standard deviation. That's a large percentage of the population within one standard deviation. What I want to do, I actually want to show you the IQ. Okay. So, it looks like one standard deviation is about 114, and this way it's about 85. So 85 score, probably 115. So yeah, 115 and 85. So if the average or mean score on an IQ test is 100, then within one standard deviation, plus or minus, positively, you'll have 34% of the population scoring 115 or between 100 and 115. And you'll have 34% of the population scoring between 85 and 100. So, there's a 15-point difference on the IQ test. Okay, so if you think about it, each standard deviation is about 15 points. So if we have 115, and this is considered both, the mean is considered average, but it's also considered average in a different way. It's considered like normal. Okay, so the average person scores within one standard deviation of the norm, because if we add these two things up, we've got 68.2% of the population all scoring between 85 and 115. Now, in the school system, 85 is pretty low, but it doesn't, those individuals don't receive funding for extra help, extra services, because they're considered within the mean, within one standard deviation, which I think is crazy, but it's funding. So this is kind of the average person's IQ, 115, 85 to 115. If we go higher, we consider 15 more points, so 2 standard deviations positively. That would be 130. So if we go down here, it's 130. So that's considered gifted. Okay. If we go 15 points more in a negative, that's 70. Okay. So, between 85 and 70, they might be struggling a little bit cognitively. They might have some kind of deficit or struggle, and, they should receive some services. So here we have 130 is technically considered gifted. I think it's like plus or minus 1 or 2. So technically you could argue like 128, because there's this margin of error for IQ scores. So technically you could get into a gifted class with like 128. And then finally, 15 more points, third standard deviation, we're looking at 145. So most people say, oh, 150 is a genius. It's 145 technically. It's very difficult to measure after that, after 145. So I don't know if anybody's ever taken an IQ test, but that's kind of what it is. Okay, so that's an example of how to use standard deviation in a 100 point test. So, what we need to talk about now is if they give you a score, any score, and they say, what's one standard deviation from this score, if this is the mean, how do you figure that out? Or does this score, if this is the mean and they give you another score, how many standard deviations does that fall away from the mean? So it's going to be some question like that. How do you figure that out in your mind? Well, I'll show you. Boom, boom, boom. Okay. So what this does, loads. Okay, so you'll notice this is not, 34 point, whatever. This rounds off the percentages. So you only have to memorize 3 numbers to figure out any standard deviation. And you'll get it like really close, like within point something. So all you have to do is remember 34, 14, and 2. That's it. 34, 14, and 2. And that's 1 standard deviation, 2 standard deviations, 3 standard deviations, 3 numbers. That's it. Because if you memorize these 3 numbers, it's the same 3 numbers on the negative side. So either way, if they say plus or minus, you've got the same numbers to figure it out. So by rounding it off, you can probably figure it out in your mind. Because you got 34%, 14%, or 2%. So you could also figure it out depending on how they ask the question. If it's an IQ, it's always 15 points on the IQ scale in each direction, but not every test is like that, only the IQ. That's why I just memorized 34, 14, and 2, and that's it. Those are the normal standard deviations, plus or minus. All right. I know that's a little complicated, but that's about as simple as I can make it for you to get that question right. Or you'll be able to come close to say it's A, B, C, or D, basically. All right. So how are we doing so far? Any questions? All right. Some of you might have been a math major or something. Maybe you can help me out. So, all right. So look at the chapter on basic stats in your book, because, see if you can see this or not, it has pages and pages of all the different types of graphical representations of stats. So here it has like a bar chart, okay? It's got basically correlations. One of the questions on there is always, where are we here? Okay. So is it a positive or a negative correlation? Okay. So, so positive correlation always go up, left, or right. Negative correlations always go down, left, or right. It's that simple. That's all you have to remember to answer that question. A positive or a negative. Does it go up or does it go down, left or right? All right. So I know that nobody will like this, like other professors would not like this advice. But, there's a whole category of counseling and psych stats called inferential statistics. And so it's very difficult to figure out. But it's like ANOVA, MANOVA, ANCOVA, and it's a different formula for every single one of those. And if you're going to miss one question on the comps, just skip over inferential statistics or guess. Just guess, because honestly, it would take you too long to figure it out, and then you'll be rushing for the rest of the exam. So, that's my recommendation. Guess. You've got 25% chance of getting it right.
You have time.
Yeah. Yeah, do it at the end if you have time. Okay. I'm just trying to see what else. I want to show you T-scores and Z-scores. Excuse me. And I think those are the basic stats, as the chapter is called. But I want to show you a quick method. It might say, hey, this is the T-score converted to a Z-score. This is the Z-score converted to a T-score. So there's a really easy way to go about that. So let's see. Really plus or minus 10, or yeah, plus 50. All right, so T-score to the score formula. This always shows up. Okay, so share this. But this is a really simple way to get the question right. Okay, so a T-score equals, so I just remember T equals 10 times. T equals 10 times. That's a good way to remember it. T equals 10 times whatever the Z-score is plus 50. So that's it. So, and then if we do the same thing, we say it's just the opposite. Z-score to T-score. So, so here's the
I used to spend dozens of hours every single week.
Video, but it's here. T equals 10 times Z plus 50. Z equals 10 minus 50 divided by 10. So I just remember one of these. I just remember T equals 10 times. That's what I remember. And because Z is the opposite. Z equals divided by 10. So that's how I remember it, and that will get you close enough to the answer. Yeah. All right. And then, I would just say, look through my notes. That should have everything else that maybe I didn't mention or wasn't mentioned in the chapter. But I used a number of things. I used my master's classes in assessment and research. And then I used my doctoral classes in assessment and research. And then I used that book, The Encyclopedia of Counseling. And Rosenthal has a chapter just on, assessment. So the combination of those three things I compiled, and they're in my notes for you. And yeah, that's about it. So look at the notes. I think it has most of what I just shared with you. And even though stats are painful at first, but that will get you through that section on the exam. All right, questions, comments? Did anybody have like just a class in stats? Do they want to, how do you two feel about should we include anything else, or do you have any helpful hints that the way you remembered anything?
No, I mean, the only thing that was like, p-values, that was like the only other thing that I know, like, but I know that's going out of favor here now. In terms of how it was, so.
How about you, Fritz, anything?
If you went through the psych undergrad track here, they really emphasize taking stats classes. I know that a core gen ed course was statistics, just a regular mathematics course, and then there was descriptive stats and inferential stats.
Yeah.
So all this stuff, all went into it like a couple times.
Like, is there anything that stands out that you're like, oh, that might be on the comps that maybe we didn't talk about?
Z scores, Z stats and Z scores definitely gonna stand out.
Okay. All right. Well, that sounds good, everybody. That's the lectures, but I am going to stay here. And you can talk to me about your projects if you like.